So yeah, hey everyone, welcoming you all to the channel. Now in this particular video, what actually we are going to do is something really which we haven't done in this on this channel, or you won't even find this type of content onto the YouTube. And we are going to write our own smart contract for an NFT marketplace onto the APTOS chain using the Move language. It's kind of a very new tutorial. So yeah, let's simply get started with it. The first and foremost thing that we need to keep in mind is how do we actually structure our Move code. So yeah, we have three files coming up, three structures coming up. One of them is modules. It's basically the directory for the modules. We'll talk about what actually all these things are later. Then we have the scripts part. Scripts is for the transaction scripts, and then we have a hold, and which actually is used to hold the compiled sources, right? So after this all, let's simply get started with it. So first of all, what we need is we have for this particular tutorial we will be creating one folder and two files. So the folder will be for the contract, that to store our marketplace contract, and one will be the move.toml file, and one will be the package.json file. Okay, so let's simply get started with building those all things that we need. One was package.json, right? The other was move.toml, and then we talked about creating a folder for a contract, right? And inside the contract, let's create the smart contract, right? So that is the NFT marketplace.move language, right? So we have these three files coming up over here, right? I'll just increase the size. Cool. Okay, now let's talk about the package.json file first. Even before going to the package.json, let's talk about the TML file. What actually here is we are going to put. So TML file basically is for structuring and putting down the configuration and everything around that. So let's get started with it. I'll also be providing you a GitHub gist with this. Okay, so first of all, let's go with the package. If there is anything that you didn't cut right now, definitely it will be covered later. So just try to keep up with the tutorial and don't panic, or don't try to make a hustle or go a bit more faster. Okay, so now let's get started with naming the package. Let's name it whatever you want to write. Let's call it hello market. Cool. Then we are required to put down the version. Let's keep it 0.1.3. You can have it anything, right? Let me provide it with the license. License, let's keep it MIT. Cool. Now for the local runs, we use the address 0x1, and yeah, we can definitely go with it. I'll definitely gonna be going through that for this tutorial. Now we will go for addresses. Let's now store the addresses. Okay, so first of all, we will hold the address for this hello market thing. Let it be whatever you want to keep it. I'll be just leaving it blank for the time being. So what this actually holds is it's the address of the module that contains the marketplace. Cool, I hope you got it. Right, next we have the std. It's for the standard one. Let's keep it as 0x1. Let's do it 0x1 right now. What actually is this? So this will be for the standard library. This will actually be used in the code of the main code that we have for the NFT marketplace.move. Then we have something called APTOS framework. It's actually also an address kind, so 0x1 same here. What actually is the use for it is the address, same, it's for the address of this APTOS framework. Make sure to keep it 0x1. It's really easy, when you're working locally on with this. I'll have for the std also 0x1. I'll try to keep it same. For the APTOS tokens, we will have it as same as 0x. Let's make a change with it. 0x3. Let's go with this. Same goes for this 0x1. Don't panic about anything if you're not getting it. These are just the configuration files which we are gonna use in the future. So don't panic, right? Just go with the tutorial. Okay, now we will be putting some dependencies that our contract will be using. Let's keep it really simple. One of them is going to be the APTOS framework. One is the stdlib. Another is going to be the token, right? So let's just write. I'll be providing the GitHub gist with it. So don't worry about that as well. Because these are literally long to write. These are coming from GitHub, right? So I don't really think that we should type it out. I'll be keeping it as a blank right now. So this will be coming from GitHub. So yeah. Then we have another thing that we need to get is APTOS stdlib. It will also be coming from the GitHub. So yeah, let me just have it like this. Then we have our APTOS token. APTOS token, it also is actually gonna get from the GitHub. So keeping it as well blank right now. You can just copy all these things from the GitHub gist that I'm gonna provide you. Cool. So we are done this with this. Now let's go to our package.json, and in this also we are gonna to add some sort of useful information. Let's see what are those. First of all, it's going to be the name. What actually is this name? Let's name it as a market contract and other things. It's up to you, whatever you want to name it, right? No worries about that. Then we are going to provide the version. Let's give it the version for 0.1.1. Then we have it for scripts. As I already told about you, we have these things coming up like scripts, modules, and we have the out files. No worries around that. So move. You don't need actually to worry about what all this thing is going on. That's the structure that we generally follow. Let's keep it that for the time being. For this, another video will be coming out explaining each and everything. But yeah, the main focus of this video is writing the smart contract and how to maintain the folder for the smart contracts, right? So it will be APTOS in it. But yeah, at the same time, I will not also be trying to just close the things without even telling you how to write this package.json and everything. Okay, we have the initializing thing with us. Now we want the move about the compile, giving the data about compile. So what actually this will do is, here actually we have a command. Okay, I'll just share with you how so it is APTOS, right? Move compile -- package dir. Then we have a dot. We have, so what actually happens is over here is named, and we provide with the addresses. Now see here actually we give a name, right, which is bound with some address, right? Now actually what happens over here is, as you write down this command, what actually happens is the backend will be, just a minute, let me make it a bit clear. Yeah, so what actually happens over here is the name that you have provided, right, this name one. So this line will compile the move code and you will get a file with an extension .mbs, right? Then after that, what we provide this code with is move, and we give it publish. So in the same way, we have something coming up for this. Did I made a mistake? Yeah, I definitely made a mistake. Cool. So somewhat the same kind of what do you call that, syntax is being followed. We just need to copy it. I'll just paste it over here, compile, and here just the change will be publish, right? This is how it works, and it will publish our code to the mainnet, right? So that's how our package.json is being managed. Did I miss something? Haven't I put this? Okay, I have done Okay, yeah. Cool. So now we are done with our toml file, we are done with our JSON file. Now let's simply jump to our main code page, that is the NFT marketplace dot move. Now here comes the real deal coming up. So yeah, let's get started with it. So just like any programming language, right? We here define something called the module, and it actually serves as a container for the related code, and it allows us to group the functions and all the structs, all the other definitions together at a single place, right? Now let's so now let's try to we get started with the coding from of it, and we will get started with writing the module. So module, let's keep it marketplace. Cool. So if you would go to the official move book, you will definitely see their module coming up with the address 0x1 or something like this, right? Coming over there. But yeah, we definitely already have provided something over there. Getting? We already have something over there. What that is, we just need to use that thing, right? So what have we given the name for that? We have given it the name hello market. So let's just have it over here, hello market, right? What does this actually mean over here? Is this just aliases that we are using for this marketplace? So actually the main module over here is the marketplace. Now we will be importing some couple of items, around 10 to items. Let's see them one by one. Okay, so first of all would be use std, the standard library that we already seen as a signer. First is signer. So now this import will actually bring in the signer module coming from the standard library, and signer module will provide functionalities related to the signers in the move language, right? And signers over here are being used to verify the authenticity, authorization for the transaction. That's the basic use. Another that we are going to use is std. We'll have this for the string, right? Std string. um, we have then this just a minute, yeah, string. But actually this line means, let's go and check out each and every word coming from here. Now this std basically is the standard library module, right? It has a couple of or a lot of commonly used types and functions, such as when we have a string. Now this string, this word, it is the name of the type that is representing a string. And this, what do we call this one part, right? This basically is just a separator, not a very big problem over here. And we call it a resolution operator, and it basically is used to access the types and functions from a module. And this string over here, it is the name of the type that represents a string. Cool. Now again we will use APTOS underscore framework. So this import is basically we are using to import something called as GUID. Okay, what actually is it? So GUIDs basically are the globally unique identifiers, and these are used to generate unique identifiers for the various purposes. So the various purposes within the code. That's basically the main use for it. The full form being globally unique identifier. Cool. Another thing is gonna be use same the APTOS framework, but we need it for the coins. Let's just simply write it APTOS framework coin. What actually is the use for this? We are going to bring the coin module from the APTOS frameworks, great, and this will provide functionality for dealing with the cryptocurrencies and the coins, and it will also include the operations such as we need it for transferring the coins, registering the accounts, and managing the coin balances, right? So all these comes in this part. Okay, another is going to be the use APTOS. Same, using the APTOS frameworks we will have this account, right? What actually is this used for, right? So it will bring in the account module, right? Account is the module that we are going to use, and it will provide us the functionalities such as for the user accounts, and operations are gonna be like creating the account, managing the account resource, accessing the account information, and everything around accounts, right? uh, Now for the APTOS framework, the last one is going to be timestamp. Okay, so what basically is this going to do is it provides the functionality for working with the timestamps, and we are also going to obtain the current timestamp. We can perform operations based on time. We can even have comparing the timestamps and everything around time. Cool. Now we are done with the timestamp. What are more things, right? So now we are going to have the events, tables, tokens, tokens, coin swap, and such kind of things. Okay, so let's import them one by one. Use aptos std event self comma event handling. Now what actually is this gonna do? What is the use case for this? It is, now we want to handle the events types and related functionalities, and we get this from the aptos std, right? So event handle type will be used to emit and handle the events in the move. So events basically are used to notify, right, and communicate information to the external observer or the subscriber for that particular contract. As simple as that. We have then use aptos std. Then we will have this table thing. Okay, same goes for this self comma table. Now let me just explain you what actually this is. So this brings in the table type and related functionalities. Now it is a data structure, and we will be using it to store and access the key value pairs, and providing the methods for adding, retrieving, modifying the data in a tabular format, right? It's amazing thing that I love about this. Then we have use aptos token. Is that aptos token? We'll bring in the token module. So what actually is going to do is we will be using it for providing the functionalities for working with tokens inside the move, and we also get certain operations like creating, managing tokens, as well as interacting with um, token contracts and resources, right? Simple as that. Using aptos token. Now what actually I want is I would definitely be requiring a way for operation related to swapping, and allowing the user to list tokens for swapping and exchange the coins for tokens, right? So for that we will be bringing in token coin swap list underscore, let's keep it token for underscore swap, and exchange underscore for token. I guess, yeah, that's how we write it. Completed. So successfully we have now completed all our imports. Now let's go even further with this. We are done with this, right? Now there is a condition, right? No, we need a way or a constant, right, in such a way that it can handle the error codes. Means it can identify or indicate that the seller and buyer cannot be the same in the certain operations, right? And one thing more that we will need for creating the contract is a way in which we are gonna represent the denominator for the fees calculation, right? So let's first write down these two things. These are going to be the constants. In this way you will also learn how to write the constants. But yeah, definitely I will suggest you to go through the book around there's a official book for this Moog language. Check it out. Not be bio, right? So this is how we write it, mentioning around that it's going to be a U64 type. Let's keep the value to be 1, right? So it will be used for error handling, that seller and buyer can't be the same person. We'll see how is it gonna be used in the later ways, but yeah, definitely we're gonna see it. Then we will have fee denomination, I guess so. Denominator would be a better word to be used over here right now. U64 same. Let's keep it as 10,000. It's just an arbitrary value. You can just have any sort of thing around this. Uh, let's see how we're gonna use it. We'll try to figure it out. Okay. Now one more thing is really important when we are working on this. Now we will have certain structs over here. I'll just um, mark them down. One will be the market ID, right? And will be the market. We'll see each and everything really smoothly. Then we have the market events. Then we will also have something for offer store it, what store actually is offering over here, or the buyer is willing to offer for and a struct for offer. Then we can have the create market event struct over there, and you're definitely gonna learn something very cool about move language around this. Then we will have this let me just put it on the next line, list token events. This token event we will have it for by token event. Cool. So these are gonna be all our structs. Once we complete these all structs, we will definitely jump on to the functions that we are gonna create for this marketplace. Cool. So yeah, definitely let's take a look at each and everything around this. Okay. Where's it gone? Yeah, sure. Now let's first create this market ID struct. Okay, so what actually is going to store this market? Let's have it first. The struct market ID. Okay, now what are the two things that it's gonna store? First is going to be the market name. Let's do it like this. So it's going to be a string type, and it's going to be a field of type string, and we will use it to represent the name of the market, right? Let's keep it really simple, string. And the another is the market address, and it will be of type address. Cool. Now so here we are defining a struct market ID, but there's something more that we need to do it. We need to provide it with some sort of attributes. Like, what can be those? We can store, we can drop, or we can copy, right? But yeah, let's talk more about the struct thing, right? So struct basically here is a composite data type and allows us to group the data together, and related data fields. So it here we are going to use a keyword, very specific keyword, that is has. Now we will, through this has, we actually provide with the capabilities that the struct resources will have. And what are those capabilities that I want this particular struct to have? It's going to have store, I want it to have the feature for drop, I want it to have the feature for copy, right? So these are all the attributes that I'm trying to provide this struct. Now again, let's create a new struct that will be the market. Okay, so for the market, what actually I'm going to try to do is I'll have four kind of things over here. First of all will be a market ID, right? Then I'll have a fee numerator, I will have the fee payee, I'll have the signer's cap, right? So let's do it one by one. So this market struct over here will represent a market entity with fields for market identification, taking up the details for the fees, what are the capabilities that the signer have got. So it's going to be a resource type with unique ownership semantics and safety guarantees. How we are going to get those? Using the keys. Now, but before going to the keys, let's first provide it with each and every detail that we want it to have. That is market underscore ID. Now this market ID, it will represent a unique identifier for the market, and I'll give it a type of what we already have created it to be. It's the market. ID, right? So this basically is already a struct over there, and which has already two data types, that is the market name and the market address, right? See the syntax over here is a bit different from other programming language, so yeah, it will definitely take you a good sort of time, to get used to it. Please definitely do check the move book that you will find. Just go on Google, search for the move book, you will definitely get it. I would definitely suggest you to keep that open with you while you're watching the tutorial, to follow along with that and learning each and every syntax around it, right? Now let's get move forward. Then what I talked about was fee numerator, right? Let me give you just let's have it for the U64. Then we have the fee pay. I'll explain you each and every of these, what actually they are doing. Fee pay, I'll have it for the address type, and then I'll have the signer's capability that I was talking about. Let's keep it account type with the modules coming from signer capability. Yeah, cool. Okay, now let's see each and every of this all together. Now this market ID I already talked about. Let's talk about this fee numerator first. Fee numerator, it will represent the numerator, and we will use this to calculate the fees percentage for the transaction within the market. It has the type U64, and it is so U64 basically here means an SIG unsigned 64-bit integer, right? 64-bit integer. In this way I'll be keep pushing some sort of relevant data all through the tutorial. So yeah, okay, now this we have this. So it's basically is a conjunction with fee, what do you call it, denominator that we have this one thing, um, for determining the actual fee percentage. Then we have this fee pay address, so it will represent the address of the account that will receive the transaction fees. It is of type address, right? And address basically is a built-in move type, right? And represent an account address in on the blockchain. And what is the signer cap? It represents the signer capability associated with the market, right? And it provides the capability of for signing the transaction and accessing the resources. But there's a catch, as I already told you about. We need to be it to be a resource type with unique ownership semantics. So what are we gonna do is we are just simply gonna put a hash key over here. Now what this actually mean is we are giving it a resource operation, and it will indicate that the instance of the struct will have resource semantics, and only one resource or market type can exist at a specific address, and the operations on this resource will be subject to the move's resource safety guarantees, and it will prevent unintended behaviors, and it will ensure that we are getting the correct resource usages, right? This is as simple as it was that I told you, right? Now let's move even further from this. We were talking about the offer store. Cool. Now we are gonna have the struct for the offer store. So basically here we can store our tokens. Now it will have just one field of, let's call it the offers, and we will make it a table kind of, right? So table basically is a data structure. First let's write it down. Struct, I think that should be better. Struct, let's have it of a store, has key, and let's have it offers, table, yeah, token. I'm just making the small mistakes. I never even edit my videos to be quite honest. If there's a mistake, it is, let's try to figure out the solution at the real time, right? Now we have this offer store has key. We already talked about this has key. This for the security and the semantics over here. Let's talk about more about it, right? Yeah, so a table over here, what actually it is, so it is a data structure it allows for us to associate a key with a value, right? Key value pair. And in this case, the key is of type token ID, and the value is of the type offer. Now this offer struct will be used to keep track of the offers made in the marketplace, right? Isn't it really cool? What just happened? I don't know. So sorry. Um, okay. Okay, now we are done with the offer store. Now let's jump on to what we have here. It is offer, right? Now let's create this struct offer. I hope you are not, until now you would have got the idea of how to write it. It's just simple, right? Offers struct offer. Then you have this. If you have some sort of other thing coming up, you can just have here the keywords and put whatever attributes you want to keep over there. So that's how the structure actually works over here, right? Now we are going to create it for the offer, for the offer that is being made by a seller in our marketplace. And we will have for this, what do you need? Just simply think of it. You just need three things, right? What are those things? Market ID, right? Market ID. Then we have the seller, and then we have the price. Simple, so market ID is of type market ID that we already have created. Market ID, cool. Then we have the seller is of type address, simple. Then we will have price, right? Price is integer, right? Price can't be negative, so yeah, U64. This is as simple as it, yeah. So price is done. Now what actually we want more is we want a way for it to have the facilities of drop and store, and it can indicate that this struct can be used to store in the blockchain and explicitly destroyed when it is no longer needed, right? So yeah, let's write it over has drop comma and store attribute. Cool, simple. Now what is the next one that we need to create? It is the create market event. Okay, let's get to it. There will be something that we will be keeping on the track along with the tutorial as we proceed further. But yeah, let's just go with the flow right now. So how do we create it? A struct create market event. What are those market events? Now so this struct basically will represent an event that is being emitted when a market is created in our place. Now it will have three fields. What can those be? Market ID again, because we definitely need to identify on which market this has been created. Then we will have the fee numerator, which is specified at the fee numerator for the market. Obviously it will be U64 kind. Then we have the fee pay of the type address, which represent at the address where the fees will be paid. And similar to the offer struct, we want to have it some sort of features like drop. We want also it to have the feature for store, right, as the same that we already have been doing. Okay, let's get started with it, writing it simple. Market ID, sorry, market underscore ID, then the market ID, simple. Then we have the fee numerator. Let's give it U64. Then fee underscore pay address, comma, right? There we go. Okay, cool, we are done with it. But yeah, I just forgot one thing. As we already told, let's have it as the features for drop and also for the store. Cool, let's go with the flow now. Okay, we're done with this. What is the next one? It is the list token event. Let's do this thing. Same way struct. We have this market when we are done. So we have with the list token event, right? List token event. Cool. Now we are going to represent an event that is emitted when a token is listed for sale in our marketplace. what are all the fields that you would need for it? Let's just think of it. First of all would be the market ID. Simple, to identify the market where the token is being listed. Then we will need a token ID. What will be the type of it? Just think about it. It's gonna be of token ID, which will uniquely identify the listed token. Then what we need? We need the seller, uh, which will represent the address of seller listing the token. Then we will have the price of the type U64, and it will specify the price for the token. Then we will have the timestamp, which represent the timestamp when the token was listed. Then we will have the offer ID, right? Again, offer ID will be the same U64, and it will uniquely identify the offer. Like the previous struct, the drop and store keywords indicate that this struct can be stored in the blockchain, and explicitly we can even destroy it. So let's first of all give it the attributes as has we will have it as a drop, and the store same as above. Then we will talk about first market ID. We will have this market ID token underscore ID. Token ID simple. Then we were talked about having a seller. Let's do it really quickly. Address. Then we have price, that is U64, because we already have talked about what all things we want. So yeah, it's gonna be really easy for us to do it. Stamp is equal to U64, getting the comma, then we have the offer underscore. Let's do it with the ID. That's gonna to be the same U64. Yeah, we're done with this. Yeah, cool. No errors. So yeah. Okay. Now you're done with this. What is the next thing that you will be looking forward to do? That is buying the token. Right now we already have listed it. Now there should be a way to buy the token, and there can be an event. Right? We need to event an event for that. So we will have this in the same way. But all are the things that you need to have for this. First of all, you will need a market ID. To represent the market. ID is stored with the that is associated with the token purchase. Then you have the token ID. What is the ID for that purchase token? Then you need the seller. Then you need the buyer. Then you need the price. Then you need the timestamp. Then the offer ID. As literally you need it for the list tokens. The simple change is who is actually buying it, right? So every other things remains the same. Just a new field is being added that is about buyer, right? Let's get started with this. Strict buy token event as same drop, and we will have it for the store, and then we have the market ID. Let's keep it this market ID, and then we have the token ID. This one, token. Mouse token underscore ID. We will have it for typing the token, and shift not working. Token, we have this ID comma seller, we have it address. Then we have this buyer coming up with address type. Then we have this price U64 comma it's literally the same, right? Just a new thing that came over here was the buyer, right? That is the U64 for ID. We'll have it for the U64. Cool, simple as that. Yeah, now we are literally done with all our structs. Now let's get back to functions. What are all the functions that we will require, that we will be building? Let's now get started with it. So what do you think would all be? So it will be, as we have already done a lot, resource account underscore cap. So that's gonna be the first one. Then we'll also give the royalty, right? So let's also have that part. Go ahead, get royalty underscore fee underscore rate, and what we'll create market for that, and then we will have what are more. Let's just think about it. Then we will have to think about listing the token. Then we will have to think about buying the token. Yeah. So list. Let's give the name to list underscore token. Then we will be buying the token. Simple. Let's keep it really as simple as that. Create market. So yeah. Sure. Let's get started with it. Okay. Okay, now we are going to create this function for get resource account cap. Now this will be a function which will basically be responsible for retrieving the market resource at the specified market address, creating a signer with the same capability as the market resource. Signer can then be used to perform the certain actions, operations within the marketplace module, leveraging all the capabilities that we have granted for the market resource. Let's write it. How do we mention the function? We write fun, then resource cap. That's the name that we are giving it. Okay, now we are required to provide the parameters. What are those parameters? Now, see, signer acquires the market, right? We'll also write that part over here. So we need this function, and we want a parameter for market address. And what we are going to do is we are also going to return a value of type signer and require the market resources. So how do we actually write it? It will be so we have this market address coming up as address, then we have this as signer acquires the market, we will have this as, actually my throat has some problem. Now what we will do is, so we now need to retrieve the global resource market at the specified market address. For that we will use the borrow global function. We'll write it out, and it will allow us to access the data stored in the market resources. So it will be having a let market is equal to borrow global, have this as market market underscore address. Cool. Rather than this part, now again what actually we are going to do is that, so now we want to create a way so that we can create a new signer with the capabilities derived from the market resources, right? And it will use the create signer with the capability function from the accounts module, and we will pass the reference to market dot signer cap as an argument. And now through this we actually are ensuring that the newly created signer has the same capabilities as the market has, right? So from where it is actually coming, we have this market, we have this signer capabilities, account signer capabilities, right? Which is now the thing that we will be putting in use over here, right? So count create underscore signer, so sorry, I'll just make it as signer underscore with capability. What are the capabilities, right? That will be the let's keep it as an market dot signer. Okay, let's actually see this line again. So this line here, we are creating a new signer with the capabilities which will be derived from the market resource. Now we actually here are using this create signer with capability module function which is coming from the account module, and we are passing the reference to what, this market dot signer cap that we have created previously. So in this way, what actually we are doing is we are ensuring that the newly created signer has the same capabilities as the market resource, right? In this way, we have completed our get resource account cap function. Cool, congratulations. Now we have got a bigger deal to be done, that is about uh, getting the royalty fees rate. Okay, so let's just write it function get royalty fees rate. So what actually we are going to provide it with is token ID that will be providing it, and we will be trying to return a U64 which represents the which will represent the royalty fees rate. So let's try to write it out. So we will have this token underscore ID token underscore it's not token underscore, it's just token ID, and we are returning a U64. U64 here basically is about, we are describing the royalty fees rate that will be returned by this function, right? Ready? Simple as that. So yeah, let's just get started with it. So just a thing that there's an error. We don't really need to do this thing because in move language where we don't have this comma semicolon, it means it is returning something. If I'm doing this, it means there's nothing being returned over and it's an error, right? But yeah, now it is returning actually something. Cool. Just need to keep these small things in mind for a better it's really in the as soon as you get started with the move book, you will definitely get the idea about how you actually go ahead with the code. Good. So let get royalty fee rate. What are the first thing that we want over here is let royalty. Let me first just write this one. I'll then explain you what actually this mean is. Get score royalty token underscore ID. Yeah. So here it's we are calling the get royalty function coming from the token module, and we are passing the token ID as the any argument. And we are now retrieving the royalty information associated with the specified token ID, and we are storing it basically in the royalty variable. Cool, simple. Now we will take the royalty denominator, and with the help of that we will be calculating the actual fee rate for this. So yeah, let's write it down. Royalty underscore denominator, I hope I am writing the spellings correct. Forgive me for some sort of these kind of small errors, which I definitely don't want to do, but yeah, these are inevitable. Get royalty denominator, and I'll be providing it with something royalty. It's right here. Cool. What actually this line is over meaning over here is, so we actually are now calling the, now see, a lot of things might now up till now would have been very clear, like what actually the words over here means. We just need to put our thought procedure on how to structurize the things and how to use the things. Otherwise it's just a game of syntax and knowing what we want to just retrieve, or we want to import, or we want to get. So this line basically is talking about we are taking this get royalty denominator function from the token module, and we are passing a reference to the royalty variable as an argument. Now it retrieves the denominator value of the royalty fraction from the royalty information, and it will store it in the royalty denominator variable. Cool. Now we need to put a if condition of over here. Let royalty. Now let's calculate the royalty fee rate. How we are going to do it? Um, so how this will be done is we'll have this if condition over here. Royalty denominator. Let's see if this is equal to 0, right? If this is equal to 0 and then you are trying to divide it, it will definitely give an error. So what I want over here is, if in any way if the royalty denominator is 0, then I want the royalty fees also to be 0, because I don't want to go through all the hassle of dividing with 0 or something. I don't really want those all errors, so let's just eradicate those all errors and keep it like this. And we will have this token get royalty numerator. I'll have this get royalty numerator coming up as from and I'll be passing so I'll be passing the reference for this royalty, and I'll be just dividing it by the token get royalty denominator. So now you have seen this coming up, right? Why actually I was not in any motive to do this thing, right? So this thing is also returning something, right? So here that's why we are not having any sort of semicolon over here. See, we actually were doing this division over here, right? So if the value that we would be getting from here, right, or there, here, if it would have been 0, and now I would be trying to do this operation over here, it would have definitely given me an error, right? If this thing I would have directly written over here, it would have definitely given me some sort of error. But now in this particular way, either you will have the royalty fee equal to 0, or you will have this in this format coming up. Now what's the final thing that we need to do over here is just return this thing, right? That is royalty fee rate. Simple. Make sure you don't put the inverted that semicolon over there, because we are returning the thing. Okay, what was the next function that we were going to write? Royalty fees is done. Create market is the function that we are looking for. Create that is the function create market. Cool. At this point I want you to know something. So here we will be creating a public entry function which will actually be taking a generic type, coin type, as a parameter, and now it will be a function that will be invoked externally to create the market. That's the reason why it won't work as a normal function. We now need to create it as a public entry function. Cool. Create market, and I said what we are going to take is a generic type, coin type, right? So I'll have a talk about it, what actually it is. Coin type. Let me just type it out. Type. What is this? Okay, so basically coin type is a generic type parameter, and it is used in the function signatures. And so what actually it is helping us do, it is basically keeping the function to be flexible and work with different type of coins. And now the actual type will be specified when invoking the function. For example, let's say if the coin type is specified as Libra coin, it means that we can work with the Libra coin types, right? So what we actually are trying to do over here is, I want this particular function to be very flexible when I am working with different kind of coins. That's the whole reason for doing this. And what will be the parameters, right? I want a sign over here, sign comma market name. What it will be, just think about it. What's it gonna be? I just think about it. What actually it is. Just go through it. Think a bit about it. What actually are going to be more? So there will be more coming up. I'll just put it to okay, I'll be adding more. So yeah. So market name it will be from string. What will be the more? Just think about it. So this will be fee numerator. It will also be coming up. So it will be like u64. And then what will be fee pay? Right. Again, fee pay will be dress. Then initial. We will have a new one, that is the initial fund over here. Okay, yeah, it's the initial fund. I'll have it for u64. Cool. It's all done. Now acquires, market, events, comma market. Okay, now we are good to go and type out the actual code for this thing. I'll just have it over this. Just trying to maintain the code properly. There might not be any sort of confusions, right? So it was about this. Now let's get started with this. So let's just simply talk about this. So we have this market name string, we have this fee numerator, u64, fee pay and everything. So we actually are declaring the additional parameters required to create a market. Now market name will be for the string, this initial fund of type 64, which will be the initial funds to be transferred to the market and acquires. So this line definitely means that the function acquires the resources, market events and market, and allowing it to mutate and access their data basically. Let's get further with working on this. So first of all thing we want is to retrieve the address of the sender by calling the address of function, right? So we have a function called the address of, which is actually coming up from the sender module, and it will store it in the sender address variable. So let's write it sender addr, let's keep it this way. We already talked about it's coming from the signer module. What actually is coming from the signer module? It is the address underscore of, and what we are going to provide it with the sender. Who is the sender? It is coming up from over here. So this is the module. We are using the function address of coming from the signer module, and we are providing it with the value sender, and then we are actually going to store it in this particular variable. Simple. And the same way what we are going to do is we are going to create a market ID instance. We are going to name it market ID, right? How it's going to work in the same way that we have already done. So I'll just write down over here, and you will be able to think about what actually and how actually it is working. Market ID, it's not really that tough, to go through these all. Market name, market address. We have for the market address, we have sender address. Cool. So we're done with these two things. Now we have certain conditions coming up over here. Let's see each of them one by one. First condition. So we need to check if a market event resource exists at the sender address or not. Right, that is one of the things that we need to check. So how do we check it? We will also be using a move to thing, right? So if the market events resource does not exist, right, we need a way to create a new market event resource at the sender address using a function. I'll talk about the function. And in the same time, we will be initializing the event handlers associated with the market events. Cool. So the thing that we just talked about, let's try to code it down. If not exists, what? Market events. Cool. With the sender address this way. So if the market event resource does not exist, what we are going to do is we are going to create a new market event resource at the sender address using a function. What is that function? It is the move underscore to. This is the function that we are going to use, and what we are going to pass is sender comma market events. And what are going to be here? Create underscore create underscore market underscore event. What this will work is account new underscore event underscore handle. These are just predefined things. It's really simple, right? We are using the function new event handle coming from the account, right? So not really a big problem for us to understand what actually we are trying to write. Create market event, that was something that I was willing to write. For whom? For the sender, right? There we go. The first thing that we will do, what? List token underscore event. We have this event, same way we will be doing it for the account. And we have new event handle. What is this? This is meant for the list token event. For whom? For this particular sender. By token, now we want by token event. Same way, coming from the account, new event handle, coming for it to by token event that we already have created. Same for whom? For the sender. We are done with each and everything. So specifically we are done with these things. I have not made any sort of mistake while writing this complete thing, but I do really think that I have made a small mistake over here. It might be it's the function coming up from here. It is the if condition. Yeah, it's all perfectly good written. Move to, okay, yeah, now I got it. What actually I was forgetting. I was definitely looking for this thing coming up. Move to, we have this coming up from move to. Yes, that was the part I was thinking about. A mistake, this was the thing. Yeah, this is how we actually write it out. I just made that small mistake, so sorry for that. No, but yeah, let's now continue. Okay, now we are done with this, but now after this thing that we have checked the market events, what actually is the next thing that we need to check? It's for the offer store resource. Does it actually even exist at the sender's address or not? If not, what we are going to do is same with that what we have already done. We are going to create a new offer store resource at the sender address using the same move to function. Let's, without wasting the time, let's type it down. If not exists, what? Offer store. If it doesn't exist, what are you going to do? On whom? About whom we are talking? It's about sender address. If it doesn't actually exist, then what you are going to do is you are going to use this move to function and create a new offer store. But for whom? The sender. And what you need to create is offer store, right? So how do you write the code for that? Offers, that it was having the table, it was of type table, right? Just remember that things that you are actually walking around, so yeah, this way we are done with this. We've I don't really think so there's space is required, and yeah, we are done with this part as well. Okay, now we have the offer store coming up with this. Now after this, what we are going to check? We are going to check if the market resource exists or not. Again, that's the part. So we have the market events checked, we have the offer store checked. Now we want to check the market resource. Let's check it out, how it's going to be done. So I'll first be writing it out, and I will definitely be trying to explain it to you in even a better way. Market, we have it over here. Then we have the sender, we have this address coming up. Now let First of all, what we are going to do is now, if the market resource data does not exist, we have to create a new resource account. How we are going to do this? I'll just check it out right now. And now, once we're done with this, we will have a tuple which will contain all the resource signers, the signers capabilities and everything. What is the next step that we should take? It's about tokens, handling the tokens. Then what are those? If there's nothing like this going on, then we have a very simple thing. That's the move to function, which will help us to do it all, right? Then we will have the market events. Then we will have the emit events. So let's do it one by one. I'll first code it down. Then I'll try to explain each and everything, because now it's gonna be really easier for you to understand each and everything. So resource signer sign underscore cap account, we have it for create underscore resource underscore. By now you might be understanding what actually this line actually is going to do is sender. We have it as, let's keep it at x01 or 0x1, whatever you would love to keep it. Take it your way, right? But yeah, for the time being, I'll be doing 0x01. Let me give this. This is not actually returning, so yeah. Token, we will have this initialized underscore token. Score. You might be now understanding what actually all is going on right now. And resource, I know we have. It actually is also not. What do you call that? We are not returning anything. Now, if this doesn't happen, so we have to move to sender, comma, market. Market, we have this coming up like this. Then market ID, fee underscore numerator, fee underscore payee, and then we have signer underscore cap. Cool, we are done with this part. Now let's complete this first. Market underscore events is equal to borrow underscore, I guess we have written this borrow global thing, right? If you would know where we have already written it, that's a good part. Market events, we have sender address, and let's have this event. I'll also talk about this part specifically, but yeah, just give me some time. I'll just first write it down. I think this is gonna be even more easier to understand then once we have the complete code, right? Mute market underscore events. Yeah, one thing, please make sure you have your, again I'm telling you, keep the Move programming language book with you alongside when you are studying about it, and make the notes, check out wherever you are getting stuck. Market event, for this market event I'll go and have it as market underscore ID. I'll have this fee numerator, then I'll have this fee payee. That's all we had for this create market event. Now we are done with this part. I'll just close this thing, and I'll also close this thing over here. Okay, we are done with this. Now let's try to exactly understand what actually we are doing over here. Okay, sorry. So if the first line over here, this if one, it actually is checking if the market resource exists or not at the sender ADDR address. Then we have this let. Now if the market resource does not exist, this line, it will create a new resource account. using the create resource account function from the accounts module. Now it returns a tuple containing the resource signer. So the newly created resource account, right, and the signers have the capability to sign with the resource account. Then we have the next line coming up with the tokens. Now this line, it will initialize the token store for the newly created resources account by calling the initialize token store function from the token module, right? Then we have this move to line. It's quite simple to understand now. So it will create the newly moves the this line moves the newly created market resource with the sender address using the move to function, and it will initialize the fields of the market struct with the provided parameters. What are those? Those are the market ID, we have the fee numerator, we have the fee pay, we have the signers cap, right? Now then we have this let market event. What actually is doing is, so we actually, this line borrows a mutable reference to the market events and pre-resource associated with senders ADDR, and here we are using the borrow global mute function. You can just check it out on internet, talking about this thing. Check this out, and it is actually allowing us to access and modify the data within the market event resources. Finally, we have this event coming up over here, and what actually is doing is, so we emit the create market event by calling the emit event function from the event module, and we just emitting the event using the mutable reference to the create market event handles within the market event variables, and passing the create market event struct with the relevant data. What are those relevant data? Simple: market ID, fees numerator, fees pay, and everything around that. Cool, we are done with this part, and yeah, there are some sort of more things left out to be written around this thing. So yeah, let's just complete this right away. What are those? Let's go really quick. Now the tutorial already is getting longer, so let's just be really quick and complete this part. Let what actually is going to be now we want to call the get resource account cap function. Why? To retrieve the resource signer associated with the sender address, and it will return the signer with the capability to access the market resources. First of all, let's write it. Let resource signer, what we want is get resource account cap from whom? Sender ADDR, right? Now if so, here we want to check if the resource signer's account for the specified coin type has been registered by calling the is registered account function or not. How we are going to do is, if not coin is, okay, we haven't used it, right? So is account registered for what? Coin type, right? So what we want is the signer address code of, and resource signer, we have it over here. This way coming up with the coin. I'll just explain you what actually is this. So register coin type and resource signer, right? So yeah, we have this over here. Cool, simple. Coming up with this, so now let's try to figure it out, each and every line over here, what actually we are doing over here. So this line, if not coin one, it actually is checking if the resource and account for the specific coin type has been registered by calling the is account registered function, right, from the coin module. So now you're pretty obvious, like first is the module, then we comes up with the function, and then we comes up with some parameters, right? Then we have this coin thing coming up for the register. Again, the register functions from going up to the coin. So it registers the account for the specified coin type by calling the register function from the coin module, right? And it also is actually associating the account with the resource signer. So we are almost done with this function, but yeah, there is last thing that is left. Let's see if the initial fund is greater than 0, right? So we want now to check if the initial fund is, let's say, greater than 0. Now what actually we want to do is, we now want that to transfer the initial fund amount of coin type from sender to the address associated with the resource sign. How we do it? Simple. Coin transfer coin type. We have it over here. What I said. If it's there, right? Now we want to transfer the initial fund of coin type from sender, right? So who is the sender? Signer, address of, and resource signer. But it will be here initial fund. So what we are going to do is we are going to transfer the initial fund to the address associated with the resource sign. So successfully now we have completed this function of ours. Now what are we left with? Listing the token and then buying the token. Okay, so what are those? Listing the token and buying the token. Yeah, I was right with the memory. Damn, I really have got a good memory, I guess so. So list token, same. We will have it public and free fun list token. By now you might have got the idea, like if it's about token, we definitely need to have something very important. It's a coin type. Then we need to have certain parameters coming up. What are those parameters? Let's first talk about them. What are those? We have those coming up as sender. These are going to be very normal, right? So it's not also going to be really tough, for you to now do it. We have the sender coming up. We have this market name coming up. We have already written it. Okay, yeah. It will give type string. Then you have this fee numerator coming up. That is basically U64. This U64. Then we have this fee pay coming up for the address type. Then we have this initial fund coming up to EU64. Everything the same. Okay, so we're done with this. I was just trying to figure out something right now. Do I really need to do it in this particular fashion, or should I change it to something else? Okay, getting a hold around this. I think I made some sort of mistakes over here, but yeah, not a big problem. So sorry, it was just by mistake. I made some sort of mistakes over here. That was I just trying to figure it out. Okay, we need to make some sort of edits over here. I just forgot what we were writing about list tokens. So what are this gonna be? This sender signer. This is correct. Market name, but we definitely need market name, and one more thing that we need over here is going to be market address. It will be coming from the of type address. Then we will have market name. Then we have the creator of this. Creator is of type address. Then we have the collection coming up. It's going to be the type string. Then we have the name coming up, and it's gonna be probably type, right? So it's gonna be string. Then the property version coming up over here, and it's gonna be type of U64. Then we have the price coming up, which again is the U64. It's so simple. It's simple as that. Then what are the next things that we are looking forward to do? Function, right? Yeah, that's gonna be the acquire. What are all the things that you're gonna be need to acquires, right? So it's going to be acquires. What are we trying to acquire right now? Market events, right? Another can be the market. And another is gonna be the offer store. get started with this. So let's have a small talk about all these things that's going on. Just a minute, guys. Yeah, what to do with this? So market ID, right? So what all we use, we need to get the market ID. Then we have the resource signer, we have seller address, token IDs coming up with the token. Then I definitely need to find the deposit tokens, then the list token for the swap. We have the offer store, we have the GUID coming up, then we have the market events coming up, right? So now we need to aggregate all these sort of items right now. So it should be a public enter function that we've already done. Now list tokens is the name, and what are we gonna do now is put some sort of really important things. First of all is, first I'll just have these things done over this market ID. No, not this one. Market ID coming up with this one. It's going to be with the type market ID. What are all these things? So this is going to be the market name, comma. Then we have this. And now it's not really that tough, because once you know all the things and you already have been working with some of the chain, it's really going to be very easy for you to even understand this. I definitely do understand it. We definitely need to get some sort of what do you call that? Practice. Definitely practice it's gonna make you do this really easily and smoothly. That's seller. I guess so. That's seller address. It's gonna be to be signer address underscore off. We will have it as a seller coming up like this. Then we have the seller let token ID is going to be, sorry, my mistake, token create this create underscore token underscore ID underscore raw. What are gonna be this creator? Then we have the collection. Then we have this name. Then we have this property version coming up over there. Then we have that token. So sorry. That token. Draw underscore token seller token underscore ID. We have this ID coming up with this token ID, and let's keep it as one. Okay, let's just take a quick look around all these things. What actually these are. This let market ID. What actually is this? It will create a new market ID struct instance with the market name, address, field assigned, right? Then with this let resource signer, it's about getting the resource account cap function is called to obtain the resource account capability associated with the market. Then you have the seller address, retrieve the address of the seller from the signer reference, and then with this token ID coming up for generating a unique token using the token create token ID raw function by combining the creator, collection name, property version parameters, and all such kind of things. Then we have this token last one, waiting for the token, withdraw tokens, right? So these all are the functions. These are the modules, right? Simple as that. Now what actually we are going to look forward for is, so is it done? Okay. Then we have this token deposit underscore token. We have this and resource underscore signer comma token. Although the video is really getting longer, but yeah, definitely it's worth watching, I would say. List token events. List token for the swap. Now I want a way for swap. It's gonna be the point. No, all the things are really gonna be just repetitive. Resource signer comma creator comma collection comma name comma property version, comma, we have this one, comma, we have this price, comma, let's give it a 0. I don't know this. So the first one over here, this this token deposit token, what actually it's going to do is, so it's previously withdrawn token into the resource account represented by the resource signer using the token, and the another one is for the swapping. Now the list token for swap is called with the provided argument including the coin type. Now we need to initiate the token listing for the swap. So we are going to provide it the resources, right? One over here means for the token, right? So these are all swap related kind of things, right? Then we have some sort of really coming up with very easy things that is going to be let of underscore store borrow global mute. I think this will be the store, then we will have the market address coming up over here, and table add and mute offer underscore store offers comma token underscore id offer market id. Just give me a second and I'll be explaining each and everything that's actually happening over here right now. Seller address, we have this price coming up over here. Cool. Then finally I'll be also talking about this let GU, what actually that we have already done it about the GUID that thing, but actually this is account, and in the same way account from the account model we are taking this create GUID function coming up with the, and resource signer, right? Simple market events, sorry not this one, but yeah, market events. We have this for borrow global mute, that we're talking about already. So we have this market events coming out from there, and we have this market press. Cool, we're done with this part as well. And last is going to be the emit, but let's first talk about all these things that just happened now. Let offer store with this. So this line actually is borrowing a mutable reference to the offer store resources associated with the market address that we already have, and what we are using is this borrow global mute function for this particular thing. And now this coming upon this table thing, what actually is this? It is actually adding a new entry to the offers table within the offer store, and this entry key is of token is the token ID, and the value is an instance of the offer struct containing the market ID, seller address, and the price. So as we already talked about, this table actually is a key value pair. So the key over here is this table ID, this token ID, and the value is the instance of the offer struct containing the market ID, seller address, and the price, right? Then we have this this thing coming up with the GUID thing. So what actually it's happening over here now, this line actually is creating a new global unique identifier, right, using the account create GUID function based on the resource signer account. And the next thing that we have over there is about the market events, and for that particular thing we are actually using a mutable reference to the market event resources associated with the market address, and which is being borrowed using the borrow global mute. Now finally what we are going to do is we are going to emit this event, right? So how actually we are going to do this? So we will emit an event of type list token event, right, using the emit event function from the event module, and the event is emitted to the list token event, and the event handles within the market events, and it contains the various fields such as market ID, we have this token ID, we have the seller, we have this price with the timestamp, we have coming up with the offer ID and everything around it. So let's type it down one by one. Event event at the rate mute market events dot list token events. We have this as this token event market ID. Sorry, this one, not this one. We have this market ID coming up over there. We have this market ID with all the things that we need to do is token ID we have. Then we have this seller coming from the seller IDDR. Then we have this price. We have the timestamp. The offer ID coming from UID. That's the creation num. Okay, we are not getting the creation underscore num. Okay, there are some sort of things that might not be getting covered, I think so, but yeah, definitely I'll put some sort of learning resources for you with the video in the coming time. As soon as I get the more time for recording such kind of things, I'll definitely put them ahead. So with this thing, now we have come to the finally to the last function for this particular marketplace. Now it's gonna be really easy for you to figure out each and everything, right? Now we are working for buying the token. Cool. Now let's simply get started with it without wasting any sort of time. We'll just get started with it same way. Absolutely go with the pace, right? It's gonna be the public function, public entry function, func by token, right? Simple. Other thing is, we want it to be the point type, just handling the points, right? Then we have all sort of, what do you call those, parameters. What are those? This is gonna be the buyer. Sign up, obviously. Then we will have the market address, market address. Who is it gonna be for? Address, market name. We'll have for it for the string. Then we will have what? Creator. Who is actually the creator? How do we identify in blockchain? Using the address. Then we have the collection. How do we know about it? Using a string. Already done, right? We already have seen this thing, collection. Then we have the name. How is the name in the strings? Then we have the property version, right? How we show it? Use 64, simple. Then we need the price, u64, comma. Then we have this offer ID, right? That's also going to be to u64. That's the simple structure. Really fast, absolutely fast, right? Okay, now what were the things? What we were looking for? Acquiring something. What were those? Market events. Then what were other things with the market? Absolutely the same things are going to happen, right? Because if someone is selling and there is buying, what will only change? The buyer, right? Simple thing, you know. So then what we have? Offer store. So that's a simple thing. When someone is buying, when someone is selling, the number of attributes that it will have, and the number of attributes the person will buy it. The buyer will have definitely one more attribute extra, right? Simple logic, right? So let's simply get started with it. How we do it? Now, first of all, we need that market ID. So how we do it? Market underscore ID. That market ID is equal to market ID. Coming up with market name. Coming with the market address, right? So this actually line is creating a new market ID struct instance with the market name and the market address fields, which is being assigned using the provided values. What is the next line that we need to have? Let token underscore id. Now what actually this line is going to do is, now we are going to generate a unique token id based on the creator, on the collection, on the name, and the property version parameter that we are actually providing over here. So how we do it? Token create token id raw, right? What also let's provide it with the creator. We have the creator. What is the next thing that we have? Collection. What is another thing? That's the name. That is the, then it's the property version. Simple as that, right? Then actually next thing is gonna to be the offer store. So actually what we are going to do is we are going to borrow a mutable reference to the offer store resource associated with the market address using the borrow global mute. So it's gonna be the let offer store. Not this one. The other way around, offer underscore store. So it's gonna be equal to borrow global mute, and it's gonna be forward of a store, right? So simple as that. Market address symbol. Is that all to be given? Yeah, sure. That's all. Then what are those other things that we need? The seller. From where are you gonna get? We are gonna get it from the table, right? We already have it over there for what do you call that? As a key value pair, right? So borrow only it's coming from the table. So yeah, and offer underscore store dot offers token underscore id going up to be dot seller. Let buyer underscore addr is equal to SIP signer. Address underscore off. I'm sorry guys. buyer buyer. If this coming up like this. So what actually this was doing, the seller one, if we were retrieving the seller address from the offers table within the offers store by accessing the seller field or the corresponding offer struct by using the table borrow, right? And then we were retrieving the address of the buyer from the signer reference and assigning it to the buyer address variable. Now let's make an assert about checking that the buyer and seller address are not the same. You see, if they are the same, it will trigger an error with the code that we already have written, that our seller cannot be the buyer. Let's provide that assert. We already have that keyword over there, right? At the top, assert. So for the assert, how do we write it? As this way, seller, right? If seller is not equal to buyer, right, underscore buyer address, then what will actually happen is that we have written is seller cannot be the buyer, right? Coming from there. Simple. So what actually is doing, it is actually checking that the seller and buyer address are not the same. If they are the same, we are going to trigger the error code, right? That is the seller cannot be the buyer. Now here comes the most important things. There will be two things coming up from here. One will be resource signing and one will be exchanging coins, right? Let me just do it a bit below. Right, so yeah, what I told was, now we are going to have that resource signer. From where it will be coming from? Resource account cap, keeping an address over there as a parameter. Now this line actually is calling the get resource account cap with the next market address, with the market address argument to obtain the resource content capability associated with the market, right? And one thing more we have is going to be for the exchange coins for the tokens. Simply whenever I'm going to implement anything for the coin or the token, what I need is the pointer for the ease, right? What will I have to provide it? I would have to give him the buyer. Who is the buyer? The price. And who is the signer? Address underscore of um and resource signer, coming up with the creator, right? Then we have the collection, then we have the name, mention everything that you are doing, right? Then we have the property version, comma. Let's give it the value for let's give it 1, right, for the time being. So yeah, we are done with this exchange coin as well. Now there are two things more left out to be done. So actually over here what is happening is, so we are invoking the exchange coin for token function with the provided arguments, right? Like we have the coin type, we have resource account capabilities, we are also providing that for this. Now we are into the some important phases. These are the royalty fees, market fees, and the amount and the coin transfer. Then we will also have to make changes in the table that we already have. So yeah, let's just start with it. Simply let royalty underscore fees, not the rate, just the fees. What will be the price they have to pay multiplied by get royalty fee rate coming from there, and we will have to provide it with the token ID. Simple as that. Cool. What will actually happen from here? So here this line actually will calculate the royalty fees by multiplying the price by the royalty fees rate obtained from the function that we already have provided. Right now we have the market. What actually will this do is, we are going to actually make a global reference to market resource associated with the market address. Is being borrowed using the borrow global. So how we do it? Borrow global. We have this borrow global over here coming up. Market address we have. So yeah, let's go in that particular way. Then we have the market fees. We are trying interested in the market fee. Then let's coming up with the price. It will be price multiplying what's the logic gonna be, right? So it's coming with the price into the market dot fee numerator divided by, we have the fee denominations. Just got a bit confused, sorry. We have done this, so what will be the now the actual amount? It's gonna be equal to price that we have minus the market fee. Is there something also going on? Oh yeah, we also had the royalty fee, right? So yeah, that's going to be the actual amount. So now let's make some transfers. Right. I guess so. We are done with this. So yeah, now what we are left with? Making the transfer simple, a very simple transfer. What we need to provide? We need to provide the resource. I know we need to provide the seller. We need to provide with the amount. So we have to transfer the calculated amount of coins, coin token from the resource signer to the seller address using the coin transfer function. Simple as that. So yeah, coin, we have this transfer. We have this coin type. Coming up to be the coin type, and what we actually are going to do is and resource. We had this resource signer coming up over there from the seller to him, and this amount over there. Now we have stable. Why the stable? Because now we actually also need to remove the entry corresponding to the token ID from the offers table within the offer store, right? Why do we simply waste space and everything, right? And how does this work? Simple, mute offer underscore store dot offers We have then this token ID coming up. So token ID is very important, right? It has played a huge role from starting to end for building this thing. And then we have this let market events coming up with so yeah, let market events coming up with this, and it's basically going to be again a mutable one. So how it's actually going to work will be, we actually going to associate with the market address, simply coming with the borrow global mute, right? So how it's going to work: borrow global mute um, with market events, the market events coming up over there as such thing, with market address, simple. So sorry, address coming up like this, simple. um, um, so we are done with a lot of things now. What we are actually left out is just with the emit functions, right? Emit. Now let's have the event being emitted. Event coming up to be the emit for event. It's going to be the and mute market events. Yeah, let's skip it that way. Market events dot by underscore token events, and then we have it was the event now by token event. Cool. Event coming up this way. What actually is going to happen now, right? So now here we actually are, to calling to emit the function from the event module. And what are all those things that we need to emit? Quite simple. One of them is the market ID, then we have the token ID, we have the seller, we have the buyer, we have the price with the timestamp, we have offer ID, and we have done the contract. So let's just simply write those down. Market ID, we have this ID coming up, then we have this token ID, there's this token ID coming up with there, we have the seller, then we have the buyer coming up, and at the same time we have this price. We have to give the timestamp for this. Timestamp is going to be the timestamp of it now in microseconds. Let's do it that way. Microsecond idea. Yeah, I forgot to write this down. Then we have the offer underscore ID. We are in with this. For the buyer, I also need to provide the buyer address, right? Yeah, that is the complete smart contract in the Move language. I hope you enjoyed it. I'll also be providing the learning resources with it, and if something is left out that I haven't told or made clear in this video, I'll definitely be writing a blog for that especially. Or if you want, just comment it down. If you want a complete playlist for Move language tutorials, I'll definitely work on that as well. But yeah, let's see how it goes. Yeah, practice. A lot of practice is required to be a good smart contract developer. Yeah, see you guys in the next video.